Okay, here's sig number 6. I'll just go through it real quick with you. Basically, it's definite integration, right? Which means that we have limits. We have an upper limit and a lower limit, right? We have some number here and some number down here. Remember, this is called the lower limit, and this one's called the upper limit, right? And so definite integration means you have those limits, which means you have to do a little bit extra after integrating. Okay, the first problem here is actually an application problem. It's trying to get you to remember like why we're integrating, what it tells us about things. One thing it tells us is the area under the curve of anything, right? So on this graph, you're given the graph of 2 square root of x, which looks like this, and we're trying to find the area between 3 and 5. It's already marked on here for you like this. So basically, we're going to set up an integral. We're trying to find the area from 3 to 5 of this with respect to x, right? There are some cases that we will do later that are with respect to y, so it is important you write that. Let's go ahead and write this in a way that we can integrate, which is with a power. And actually, now that I'm doing this, I'm gonna go and write that 2 on the outside just to make it easier, right? So this is gonna equal 2 times integrate x squared. That means you add 1, divide by whatever you get, right? If you add 1 to 1/2, you get 3/2. So it's going to be x to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3. And then what we're going to do is we put this little bar over here to hold on to our limits of integration, right? We're going to limit like from 3 to 5. It's probably easier to clean this up first, right? We're going to get 4x to the 3/2, and since we have to evaluate this, why don't we go and write it in radical notation again, right? So that's going to be 4 square root of x cubed over 3, right? Just changed it back to radical notation, right? This 3/2 became basically, if you want to write a little 2 up here, it's 2. And we're still going from 3 to 5, which means first I plug in 5, right? So we're going to have 4 radical 5, right? 4 squared of 5 raised to the 3rd power minus 4 square root, oops, I meant to do that in black, 4 square root of 3 to the 3rd power. And you know, without a calculator, you're not really expected to do anything else farther than that, right? So you know, if you could like take the square root of 5 and then cube it, you would want to do that, right? Like if it were the square root of 4 cubed, then you would want to say, well, that's 2 cubed, which is 8. But we don't know what the square root of 5 is. So we don't know what the square root of 3 is. There's no fractions that can be simplified. So we're just going to leave our answer like this, right? And that's, if we had a calculator, we could find an approximation, but that's really, you know, a good answer. So I guess you could do this, right? You could say, well, that's square root of 5 cubed minus 4 square root of 3 cubed all over 3, right? They have a common denominator, so you could do that if you wanted to, but this is fine. Okay, now we're just basically in the process of it, right? How do we do this process-wise? I am going to encourage you to just, you know, maybe not on your paper, but in your head, do that, right? Just factor out that constant, right? This doesn't work with variables, it works with constants. And then it just makes it a little bit easier. So the integral of e to the x, if you passed your previous test, is e to the x. So, you know, we're left with this, right? Negative 3 e to the x. We're going to plug in 0, so it's going to become negative 3 e to the 0 minus negative 3 e to the negative 3. This double negative is going to turn into a positive. You do need to know e to the 0 is it's 1, so this is going to be negative 3 plus 3. Let's go and write it as over e to the 3rd, right? E to the negative 3 is like divided by e. It's like the same as 3 over e to the positive 3. And again, without a calculator, you can't really do any better than that. You could like find a common denominator and stuff, but that's pointless. We're not trying to learn that stuff. So next one, let's do this. If you can recognize that it looks like this, right? You're basically just factoring out the negative 5. then hopefully that helps you see that this is the integral of 1 over x is natural log absolute value of x, and we're going from -4 to -1, right? Remember, this is just this thing over here is just holding on to our limits, and so basically we're going to plug in -1 right there. Right, plug in -1 first, subtract -5 ln, plug in -4 right there. Right, lower limit goes second. Clean it up. This double negative is going to be positive. Go and do our absolute value things, right? The absolute value of -1 is 1. This is now plus 5. Natural log of absolute value of 4 is 4. This one you must know, and you must simplify it. Natural log of 1 is 0, and so this thing turns into 0, and you will get it wrong if you don't do that, and so we're left with this. Okay, the other one you need to know, so you need to know that natural log of 1 is 0, and you need to know that natural log of e is 1, right? Those are the two basic ones that if you don't simplify those, it will be marked wrong, right? So our answer on that is just 5 natural log of 4, positive 4. You also need to do the absolute value piece, right? All right, number 4 is going to be one that people are going to struggle with because you actually have to plug in numbers to a function, to a trig function, and not everybody's real strong with that. So again, first thing, just put that constant on the outside. You don't have to write that step again, but I'm going to write it so you can see what it looks like. So we're trying to figure out what's the antiderivative of secant tangent. Well, if you passed your last one, you know that it's secant, right? Derivative of secant is secant tangent, so the integral of secant tangent is secant. And we're going to be evaluating this from -π/6. Should do that in a different color just so I can show the evaluation part. -π/6 and -π/4 on the bottom. So this is going to become 2 secant of π/6 minus 2 secant of it's -π/6 over here, -π/4. And yes, you can't leave it like this. You actually have to evaluate what is secant of -π/6, right? So what do you know about secant, right? That's the question I'm going to ask you if you're struggling with this. What do you know about secant? Well, secant is 1 over, let's do some side work, right? Secant x is the same thing as 1 over cosine x. So basically, secant of -π/6 is the same as 1 over cosine of -π/6. And so we need to know what's cosine of -π/6. Well, unit circle. If you know π/6, you can figure out -π/6. That's not π/6. π/6 is here, right? The coordinate for that is √3 over 2, 1/2. Right, this is the angle of π/6. -π/6 is just down here, right? You're going to go downwards by π/6. So what are the coordinates there? Well, it's just going to be √3 over 2, but we went down, so it's -1/2. The cosine is the x coordinate, so it actually doesn't matter, right? So the cosine of π/6 is actually √3 over 2, but don't forget it's 1 over cosine of π/6, so it's 1 over √3 over 2, which is the same thing as multiplying by the reciprocal 2 over square root of 3, right? So this piece turns into 2 over square root of 3 minus secant of -π/4. Same reasoning, right? Like positive π/4 is here. The coordinates are √2 over 2 and √2 over 2. -π/4 is down here. The coordinates are √2 over 2 and -√2 over 2 because you went downwards instead. And so secant of -π/4 is the same as 1 over cosine of -π/4, which cosine of -π/4 is √2 over 2, but remember it's in the denominator, so this is going to be 2 over √2. So this turns into 2 times 2 over square root of 2. And that should be enough. We don't need to find common denominators. Actually, there's one thing we should do to simplify this. Go to multiply here, right? This is 4 over square root of 3 minus 4 over square root of 2. That is a perfectly acceptable answer right there. All right, so learn your unit circle and learn how to evaluate functions at the special angles like pi over 6, pi over 4, pi over 3, pi over 2, and negatives of those as well. All right, good luck.